All right, so we have seen that basic pen and paper methods are not that easy and key space is small. So question is, can I come up with a very simple algorithm where the key space is really large? So simple monoalphabetic substitution is for this, and it is used in the past a lot, okay? Idea is as follows. Write the alphabet here, then write the alphabet in a random permuted way of your choosing. And this way, whenever you want to send a message, write it as a plain text. But in your plain text, then replace every A with K, every B with U, every C with E. So it will look like a random looking text, right? So this letter you will send, and when the person receives it as a cipher text, they will replace every K with A, every U with B, and so on. So as you can see, it looks fantastic. So question is, can I make a brute force attack like we did in the previous cases? So answer is yes, but you have to try every possible key combination now. So question is, how many keys actually are there, right? So for instance, below A, you can actually write 26 different letters, right? Below B now you can write 25 because you use 1 here, 24, 23, and so on. So as you can see, this is 26 factorial. And the thing is that 26 factorial is a very huge number. Even with modern computers, trying all one by one will take a lot of time, right? So as you can see, brute force does not apply here. So you might think that, okay, then we have a fantastic algorithm. Why not we use it in practice today in our computers? Because although we cannot break it by trying every possible key, we can find a weakness in this approach and break it that way. So the weakness is as follows. There's a redundancy in every language, okay? By redundancy, we mean that not every letter is equally likely in a language. And you can use this, which we refer to as frequency analysis, and break the system, okay? So let me show an example. When you perform a simple monoalphabetic substitution and you remove the empty spaces and punctuation mark, this is actually what you see as the cipher text, okay? So as you can see, when you look at it, it is not that easy to break. But what we know is that every O, for instance, represents the same letter in the plain text that we don't know. So what we can do? So we said that we want to use the redundancy in the language. So this is a very old breaking technique, and it even appears in the 9th century book titled A Manuscript Deciphering Cryptographic Messages, written by Al-Kindi. So as far as I know, it is one of the oldest cryptanalysis books, might be the oldest that survived. And actually you can have see a copy of it in Dolmabahce Palace. And you can even pay money and take photocopy of its pages. Okay? But you can also find a PhD thesis that actually works on this. So it is very famous. And as you can see, the algorithm I just mentioned was broken as early as 9th century. So idea is as follows. We are going to use the redundancy of the language. So before even capturing the text, you actually get the frequency of a language. So for a given language, find a very long text and count the number of frequencies of every letter. So in order for this to work, the text should be really long so that we get rid of unnecessary statistical things, right? For example, in English, E is the letter that appears the most. The second place belongs to T. I think E was like 11% or 10%, T is 9%, and so on. But if you do it in Turkish, A is the most appearing letter, then E, and so on. Okay? So you have done this. You find the statistics, frequencies of every letter for a language. Now, if the ciphertext is long enough, which you capture, the letter that appears the most in the ciphertext is most probably corresponds to E in the plain text if it is written in English. Okay, you don't even need to know in which language the message was written, because you might assume that it is English and perform this attack. But if it doesn't work, then you can calculate the frequency of Turkish, French, Spanish, and so on, then perform the attack anyway. Actually, just by looking at the frequency of the letters in the ciphertext, you can even guess in which language it was written. Okay. So assume that it was written in English. So if the ciphertext is long enough, the letter that appears the most in the ciphertext is most probably corresponds to E. I say most probably because sometimes, these statistics are close to each other, right? So you have to actually try one by one. So some people think that this directly works, replace letters by letters. But actually, at the end, you have to do some manual computations. The letter in the ciphertext with the second most frequency is most probably corresponds to T in the plain text, and so on. So this way, you go back to ciphertext, count the number of letters, find the most appearing letter, okay? So if it was written in English, then that letter most probably corresponds to E. So you replace one by one and see if it makes sense in that language. So you have to do some manual inspection at the end for this attack to work.